This is going to be a video that shows you how to write the equation of a sinusoidal function when given a scenario or a set of data. This is a calculator-friendly lesson. As you can see in our first problem, the numbers are not so friendly, and we're going to want to take advantage of our calculator, and we're also going to want to take advantage of the graphing features on our calculator later on. So let's go ahead and get started. Go ahead and turn to page 66 and read problem number 1. Pause the video. Okay, so you can see in problem number 1, we're given a set of average temperatures in Fahrenheit for Des Moines, Iowa, and we're told to graph this function and let x equals 0 represent January. So January will be months since the beginning of the year, and January is the first month, so there are 0 months. February will be 1, 2, 3, 4, and so on. Okay. So I'm not really concerned about making a super accurate graph. You can see I don't have that many squares. The biggest number here I see, I think, is in July. So as long as I have 8 squares, I'm just going to count my y-axis by 10. Let's see, 1, 10, 20, 30, 40, 50, 60, 70. That'll be perfect. That'll be 70. We'll mark this as 10, and that can be 80. Okay. So here, so this is, what should we call this? We'll just call it months since the beginning of the year. So at January, we have about 20. And then February is about 24. 36, 50, a little more than 60, a little more than 70, a little more than halfway. And you can see we're developing a really nice sine curve. Well, it might be a cosine curve. Let's finish it off. And then we've got 54. 38, 1, 2, 6, 7, 8, 9, 10, 11. And then here in December, we've got 26.1, about that. Okay. So we can see that we've got this curve. And from the work we did before winter break, I can see that I'm starting to look like an inverse cosine curve, because remember, an inverse cosine, a negative, or not an inverse cosine, my bad, a negative cosine or reflected cosine goes bottom, center, top, center, bottom. And right here, when time is 0, I'm at the bottom. So I think I'm going to write this as a negative cosine function. So just like before, we are going to need to find the amplitude, the period, all those wonderful things. So let's lay out some ground information. First off, we have our general equation A, and then it's either sine or cosine. And then we have B, x minus C plus D. Now, as a reminder, D is our midline. A is our amplitude. B is going to be 2 pi divided by the period. And D is our horizontal translation, or our phase shift. Now, if we write this as a negative cosine, we're not going to need a horizontal translation because it just starts on the y-axis. So that's kind of handy dandy. So the first thing we're going to need is A, the amplitude. And to find the amplitude, normally we would find the midline first and then just count. But because the numbers aren't so lovely here, what we're going to do is we are going to take the maximum y value minus the minimum y value and divide it by 2. That's going to basically take the height and divide it by 2. So our maximum value is 76.1. Our minimum value looks to be about 20.8. I'm going to grab my calculator. And I'm going to go 76 36.1 minus 20.8 divided by 2. And so my amplitude is going to be 27.65. And I'm going to leave it like that. I'm not going to round it because that's good the way it is. 27. Okay, so that's how I find the amplitude. To find the midline, I'm going to do the maximum plus the minimum divided by 2. The amplitude is I'm going to find the total height of the graph and divide it by 2. The midline is I'm going to find the average between the maximum and the minimum. So the calculation is similar, but just be careful there. We don't want to mix them up. So 76.1 plus, oops. 20.8 divided by 2. So it's going to be 39.45. Wait, I feel like I typed something wrong there. Oh, yes, I did. Oops. 76.1 plus 20.8. That seems kind of low. Divided by 2. There we go. So our midline is going to be at 40, and that makes sense because like it's kind of about 50. Like here's 10, 20, 30, 40, 50. And like this looks like about the midline. So 48.45 is a reasonable answer. For the period, I can see that it takes 11 from 0 to 11. This is going to be 1 period. So B is going to be 2 pi divided by 1 period, which is 11. And I'm just going to leave it like that. There's really no reason to make that anything else. So now I'm going to put it all together. And I'm going to write my equation. Y equals negative, because it's negative cosine, amplitude, cosine, 2 pi over 11x. I don't have a phase shift. I don't have a horizontal translation here. And then plus 48.45. I also could write it, if I wanted to write it as a positive cosine, like I could do a phase shift from this point right here. Let me switch colors actually. Pink. If I was using a phase shift, I could write y equals 27.65 cosine 2 pi over 11. And then x minus 6. Like I could look at that as my starting point. So either equation is going to give me the exact same graph. So now let's see what else we're asked for. It says, using your prediction equation, find the depths at not, wait, that's the wrong problem, Doberg. Nope, that's pretty much it. But I have 2 additional questions here for you. It says, find the temperature in March using your equation and use the graph to find the temperature that is approximately 70 degrees. So my temperature in March is month 2. So I'm going to go negative 27, I'm just in black because that's the equation I'm going to use. Negative 27.65 cosine 2 pi over 11 times 2 plus 48.45. Grab our calculator. And we're going to go negative 27.65. I'm so not going to be using this online calculator. Cosine. Now, just double check your mode. We want to be in radian mode here, which is what I'm in. 2 pi divided by 11 times 2, and you don't need parentheses around the 2. You're good like that. Plus 48.45. Just double check. Looks all typed good. And I get 36 36.96 degrees. So just if I look, that's pretty close. Like I had 36.3. That's a pretty good estimate. So I'm going to go with 36.964, 3 decimal places. Okay. Use the graph to find the month that the temperature is approximately 70 degrees. So I'm going to take advantage of my straight line tool here, and I'm going to go up to 70 degrees. I'm going to go across, and I'm going to look to see when I'm at about 70 degrees. So here and here, this would be between 4 and 5. So between May and June. So it's going to be between May and June. And then the second dot occurs between 7 and 8. So, and then again, between August and September. Let's look at problem number 2 on page 66. Take a moment, pause the video, and read problem number 2. Where is it? Yes, we're not doing problem number 2. It's missing. We're going to go straight to problem number 3. Okay, so take a moment, pause the video, and on page 67, read problem number 3. Okay, so here we've got a set of times, which is very convenient that we start at midnight because that's time 0. And we go up to noon. So we immediately know that we need to have 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. This is going to be 12 noon. And then I have to go about up to 5. I have 10 squares. 1, 2. Oh, I do. Perfect. I'm going to make these. I'm going to make every one square be like a half because I just think that'll make the graph a little easier. 5. And this is depth in feet, meters. And then this is going to be time since midnight. So let's go ahead and make a quick graph. I've got 0, about 2.5. 2 a.m. is about here. Your graph doesn't need to be perfectly perfect. 4 a.m. is about here. 6 a.m. is going to be back here. 8 a.m. 10. And noon. Let's go with that. And you can see we kind of have a sine function going here because it looks like it's starting in the center and coming up and down. And it's going to head back up to the center, although it doesn't quite perfectly make it, but that's okay. So immediately I see this and I'm like, you know what? I really want to write this as a sine function because I see it's going center, top, center, down, center. And to me, that looks like a positive sine function. So that's what I'm going to do. So we're going to go through the same situation we did on number 1. We've got y equals a sine or cosine, b x minus c plus d. And we're going to start with a. Now remember, to find the amplitude, we're going to do the maximum minus the minimum divided by 2. And here it looks like the maximum is 4.4 and the minimum is 1.8. I'm going to divide that by 2. Now I'm going to be honest with you, I'm going to use my handheld calculator because me and that overhead calculator are really not just getting along right now. and I get 1.3. Now to find D, that's the next easiest thing. I'm going to do the same calculation, but I'm going to average. So max plus min divided by 2. This would be good information to put on a summary sheet if I were you. And when I do that, I get 3.1. Now, if I write this as a sine function, I don't need a C value because I think it kind of starts in the middle. So I'm going to write it both as a sine function and as a cosine function. Now, everything will be the same except the C value. So let's find B. B is 2 pi divided by the period. Now here, it looks like the period is 12 hours because we're going from 12 a.m. to 12 noon. So I think that's a safe assumption that our period is 12 hours. So if I have 2 pi divided by 12, that's pi over 6. So here we go. If we're going to write this as a sine function like that, this is my starting point. It's going to be y equals a sine b x plus d. Now, if I'm going to write this as a cosine function, because I kind of think that it starts here, if that's where my I goes, I can write this as y equals 1.3 cosine pi over 6. Now, this x value right here is at 4. So it'll be x minus 4 and then plus 3.1. Either equation is fine, whatever you are more comfortable with. So now it says, use your equation to make a prediction at the depths of 9, to find the depths at 9 a.m. and 3 p.m. So 9 is 9. That's easy. That's just t equals. But here for t equals 3 p.m., we want to remember that that's 12 plus 3 to get to 3 p.m. because it's p.m. all these times. It's like hours. So I'm going to go 12 plus 3 is 15. So now I am going to pull up the overhead calculator and I'm going to show you a fun trick. So I'm going to use, it does not really matter which one you want. I'm going to go to y equals, and I'm going to put my sine equation 1.3 sine pi divided by 6x, close it, plus 3. I'm not going to press graph. I'm going to go to my table, and I'm just going to look at 9 and 15. Oops, wait, hold on. My table settings are a little weird. You know, I could put this in the home screen, but because I need 2, it just kind of makes sense. So here at 9, I see I'm at, 1.8 exactly. So at 9 a.m. is 1.8 meters. And 3 p.m. is, go down to 15, 4.4 meters. Okay. The boat needs at least 3 meters of water to moor at the dock. At what time in the afternoon can it safely dock? So this is what we're going to do. We already have our sine equation, or you could put the cosine equation in y1. In y2, I'm going to put 3. I'm going to go back to y equals, and I'm going to put 3 here. Now, I'm not just going to press graph because that's going to give me a weird graph. What I'm going to do is I'm going to press window, and I want the x min. I just like a little bit of space, so I'm going to go -2. Now, I'm going to give 24 because I want to see a whole 24-hour period. And I know that I only need to go up to 5. So I'm going to go from like -2, just so I have some space at the bottom, to 5. Because I'm going up to 5 here. I know I don't need it to be any higher than 5. And I'm going to hit graph. And you'll see there, look at that. Look how nice that is. So I can see right here, 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 here. These are all where the height of the water is at least 3 meters. So I'm going to real quick pause it. I'm going to throw a screenshot of here so I can write on it. Okay, so I've just, made a sketch of my graph, and I just want to show you. So here, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this right here is 12 noon. That's noon. So in the afternoon, what time in the afternoon can it safely dock? We're not looking at the morning, we're looking at the afternoon. So right here, we're at 3 meters. It needs at least 3 meters. So this whole, oh, that's a big highlighter. This whole period right here, I can see that the tide has come in and the water is higher between these two dots. So the question is, from my calculator, is what are the two time values here? Like, where are these? So I'm going to go to my calculator. And again, I'm looking not for these, not this one, not this one. I want this one and this one. I'm going to go second, trace, and that's my calculate menu. And I'm going to pick number 5, intersect. And I'm going to move my cursor right over that first intersection I want. It says first curve. The calculator is saying I'm on Y1. I'm going to press enter. Second curve, it's on Y2. I'm going to press enter. Now the guess is important. Make sure you've moved your cursor where you want, like, the calculator to find the intersection, because there's a lot of intersections here it could give you, and that's the one we want. So I press enter and I see I've got an intersection at 11.85. I'm just going to go with 11.9. So, oh man, that's slightly afternoon, before noon. That's okay. Make a little note here that this is 11.9. So now let's find the other one. Calculate. I want number 5, intersection. I'm going to move my cursor to that second intersection. I can do this at any point. It just has to be done before guess. First curve, yep. The sign, the line, and you can see on mine, it's in color, that it switches to the red. And now my guess, that's the one I want. Enter, and I've got 18.1. Now, 18.1 is a weird time. So think about it. If I subtracted 12 from this, I would get about 6 o'clock. So I'm going to say, during what time in the afternoon can it safely dock? You know, I'm actually going to type this because that'll come out way better. Say, the boat can safely moor, I think that's the same thing as dock, between noon and 6 p.m. It's a little more than 6, like 6.1, but we'll just go with 6. 6 is good. Because I can see the water height is above 3 when t equals 11.9 and t equals 18.1 on my graph. Whoop. All right. So at this point, what I would like you to do is take a look at tonight's homework. I only want you to do numbers 1 and 3. So just 1 and 3 on page 68 and 69.